Rotary steel rule is used all around the world to produce a wide variety of corrugated packaging for many different types of products. One of the more common uses for this type of rule is to die cut packaging for the transportation of meats, poultry, and vegetables. Raw steel. Rotary rule producers start with hardened and tempered strip steel. The manufacturer can specify the hardness, chemistry, width, and thickness they need for a specific application. When the steel arrives, it goes through a strict incoming inspection process before it gets released into production. A technician will inspect the steel to ensure it's the correct size, that it is straight, and meets all the purchase specifications. As the inspector measures the thickness, width, and hardness, he records the reading on an incoming inspection report. Before this lot of steel enters the warehouse, one coil goes through the entire manufacturing process so the technician can bend a serrated sample, which will ensure this lot of steel will perform in the field. The test bend is tighter than that would normally be used in a steel rule die, so the manufacturer can be certain it will not crack when bent in automatic bending machines. Only after this material has been qualified will it be added to the raw material inventory to await further processing. Skiving. The first process the steel will go through is skiving or shaving. In this process, the coil is loaded on one of the machines that pulls the strip through a series of carbide cutters which remove a prescribed amount of steel, leaving a precise bevel. Here you can see the difference in the appearance of the product at the beginning and end of the shaving process. Because the process generates a great deal of heat which can affect the temper of the steel, coolant is pumped onto the steel to keep it from heating or burning during the skiving process. The operator monitors and controls the final height through the use of a laser micrometer. Once the coil meets the specification, it is secured and is ready to move to the next process. Edge hardening. Certain rotary rules are edge hardened, which means they are put through a process that hardens only the edge of the steel. This is more common in non-serrated cutting rules, but is gaining popularity for serrated rotary rules. There are numerous processes that can harden the edge, including lasers, plasma, and flame. The most common is through the use of high-frequency induction hardening. In this process, a generator produces a frequency specifically designed for the application. The sharpened steel passes under a coil that instantly heats it to a prescribed temperature. The material is then immediately drawn back to cool it and keep it at the hardness specified. You can harden the steel prior to grinding the teeth, or you can harden the tips of the steel after it has been serrated. Each process has advantages and disadvantages. Serrating. The next process is where the teeth are ground into the rule. A grinding wheel is dressed with the pattern for a specific tooth profile. The steel then passes through one or two grinding wheels that transfer the pattern from the grinding wheel to the steel blade. Coolant is used to prevent the steel from burning or losing temper during the serrating operation. This is the one process that differs from manufacturer to manufacturer, so we can't show you this much in detail. Finishing. Once we have a coil of serrated steel, it is ready to go into the finishing department. 99% of the products used by rotary die makers are either straight without back notches, SNN, or curved. If the material is going to be sold as a straight coil, it runs through a measuring line. This machine performs a number of functions. Because the steel has run through multiple processes that involve coolants or other grinding liquids, it must first be cleaned. The coil runs through a cleaning station that utilizes hot water under high pressure to clean any dirt or grease off the steel. As it exits the cleaning station, any excess water is removed prior to the coil passing by a printhead that prints the company logo as well as the product specifications and a lot number on the steel. The box quantity and the orientation of the coil depends on whether the coil is being sold in a dispenser box or is being packaged for an automatic bender. If it is being sold for an automatic bender, it must be secured before being put into a box. If the material is going to be sold curved, it runs through a punch press to form the back notches. The spacing of the back notches are critical, so highly accurate servo feeds are now used instead of air feeds to feed the rule into the punching die. There are various back notch styles available, but the vast majority is punched half-inch deep on half-inch centers. The back notching is a typically overlooked feature of the rule, but it is critically important if the rule is to perform properly. After the rule is notched, it runs through a series of rollers in a curving machine that curves the rule to the specified diameter. For this particular job, the operator is curving the rule without any back notches. While the rule coming off the curving equipment looks die ready, there are still two very important processes that will ensure the rule will retain its diameter. The first process involves placing the coil over a calibrated steel fixture that is slightly smaller than the die drum. The material is then secured with wire so it is locked at the exact diameter specified. Once the coil is secured, it goes into a stress-relieving oven for a set amount of time at a specific temperature. The stress-relieving process is extremely important because the steel has a memory. Since the steel was originally straight, it will have a tendency to want to straighten even after it's been curved. This will manifest itself in a rotary die by having the ends of the curve rule popping up out of the shell. The stress-relieving process changes the memory so the steel will want to return to the curved state even after it's pulled straight during the insertion of the rule into the shell. This helps the rule seat itself to the die cylinder, which prevents breaking during the die cutting process. Packaging. The final step in the process is final inspection, packing, and labeling the boxes. The inspector measures the critical dimensions and confirms the product is what is specified on the production order. Bender coils and curve rule get wrapped in rust protection paper prior to packaging. Since we cannot wrap dispenser coils in paper, the boxes themselves are coated with a rust-inhibiting coating. The final step is when a barcoded label that contains the description, quantity, and a lot number is affixed to the box. Once the material is packaged, it is brought to a warehouse where it awaits shipment to the customer.